extension of Chapter 5. We're going to do more factoring, but this time of something called special polynomials. Special polynomials. Why are these things special? Well, if you can help me out by grabbing a piece of paper that's square-shaped, perhaps you have a post-it note, that might work. I will draw what you're supposed to do, but I like to label each length of the side of the square piece of paper as A. So A and A. And I want you to cut out a smaller square from the upper right corner. So in here, just get rid of a nice square here. Okay. Let the length of each side of this square be B. Okay. Now, what's left over is this piece. And I want you to make one cut of this irregular shape. I want you to cut it right here. Like that. And then I want you to form it into a rectangle. You're like, huh? How do I do that? So take those two pieces. You may have to flip them or something like that. But I want you to create a rectangle. So here's one piece that I have. This piece will correspond to, I guess I should do different colors. I'll call this one green. That'll correspond to the green piece here. Okay. And then that one in yellow, I'm going to actually flip. Okay, flip. And then put it like this. That's the yellow piece. Okay. Now if I actually do that, look what happens. This length here is still A. Right? This here, however, is described as not A, but A minus B. Can you see that? This whole thing is A, but I took out this part here, that's B, so A minus B. That's what's left over here. Okay? That's the equivalent to that. And then, well, if I moved it around enough, I guess this part here is B. And so remember, these two shapes are the same, aren't they? How would I find the area of this rectangle? Well, it's the length, which is B plus A, or A plus B, equal to A minus B. How would I find the area of the shape from above? Well, that's the big square A squared, and I removed the small b squared, so subtract b squared. Well, if those two areas are supposed to be the same, then what is your conclusion here? Yeah. That a squared minus b squared is actually equal to a plus b times a minus b. This has a special name. It's called the difference of squares. Okay? So you should know this and memorize it. Or if you don't, you can always rewrite the binomial as a squared minus 0ab or plus 0ab minus b squared, and then use the factoring techniques from last day. That way you'd be looking for two integers whose product is -1 and the sum, of course, is 0. Alright? I prefer if you just use the lovely formula here. I have it memorized because we use it quite a bit. If you can see it, it's actually pretty good. Okay? Don't worry about Algebra Tiles. This is going to be another long video, so just go ahead and do it. So if you see this as a squared minus b squared, if you hopefully can see that, yeah, the a value is like your x, and the b value is not 4 but 2, because it's 2 squared, then you can easily see that this factors into x plus 2, and then x minus 2. You're done. Didn't like that? You wanted to do last day's way? Then here we go. Find two numbers that multiply to -4. The same two numbers add to 0. And you'll find the combination, of course, is 2 and -2. So this still gives you the same answer. Okay. Alright, you know I hate negatives, so I'm going to factor that out. 81y squared minus 25x squared. If you can identify a and b right away, then life is pretty easy, because a in this case is 9y, right? 9y all squared gives you 81y squared. B would then be, I think, 5x, because 5x all squared gives you 25x squared. Knowing that now, let's go ahead and plug it in. So a plus b times a minus b. We're done. Okay? Now how about C? My advice always is to factor out the greatest common factor first. Can we do that? Probably a 2. And I think it'd be cubed. And let's see what's left over. 36a squared, 49b squared. Nice! I like this because I know that then I'll use capital A this time is 6 little a, and then capital B is just 7 little b. And then now, once again, I can use that formula of the difference of squares. Capital A, which is 6a, plus b, and then 6a minus 7b. Done. Okay. All right. Next one's m squared plus 9. This is not a difference of squares. This is a sum of squares. And there's no way you can actually factor that. This is a sum of squares. Be aware, a sum of squares is not factorable. So I wanted to write this down so that you wouldn't get tricked. Don't write this as m plus 3, m plus 3. That's a problem too, because if you distribute, you don't get m squared plus 9. You get m squared plus 6m plus 9. Okay? Alright, so make aware. Sum of squares, can't factor. That's all you can do. Leave it. Okay? Whoa, E. Can you see how this is a difference of squares as well? Can you see how A equals to, well, what squared is 81? That's 9. What squared gives you p to the power 4? How about p squared? What squared gives you q to the power 4? How about q squared? So there's your A value. B? Yeah, that's easier. That's just number 4. So, once again, A plus B, A minus B. Done. F. A equals to 5x minus 2. B equals to, I think, 7x plus 1, right? So knowing that, once again, difference of squares. Here we go. It's A, and this time we use big brackets. A plus B times A minus B. Lots of brackets, but nonetheless, you can do it. So we're going to distribute and try to simplify. 5x minus 10. See that? Plus 7x plus 7. 5x minus 10. Careful here, it's negative 7 times x plus 1. Negative 7x minus 7. And then inside the square bracket here, 5 plus 7, that's 12x. Negative 10 plus 7 is negative 3. And then here we have 5x minus 7x, negative 2x. And negative 10 minus 7 is negative 17. And if you wanted to leave it like that, I'd be like, no, there's something else you can factor out. That's right. Look here, look here, look here. There is a factor of 3 we can take out. 4x minus 1. And then if you want to take out a negative from here, you can do that too. So you can take out negative 1 and then 2x plus 17. You don't necessarily have to. But that might be nice because then the 3 and the negative 1 can combine together. Negative 3, bracket 4x minus 1, bracket 2x plus 17. Wow. Done. Whew. Need a break. Take a break. Okay? And then come back. But I'm going to keep moving on, because there are more special polynomials you can do. So we've done the difference of squares. What about factoring what they call a perfect square? Remember how we expand a plus b squared? Please don't do this once again. A squared plus b squared. No! Scratch that out. Remember, the idea of a plus b squared is a plus b times a plus b. Now, when you expand, you get a squared plus ab plus another ab plus b squared. And look, that simplifies to a squared plus 2ab plus b squared. You do the next one yourself. You like my strategy of writing a minus b twice? Go for it. Remember, BA, AB, same thing. Multiplication is the order doesn't matter. Very similar to A plus B all squared. So what I want you to realize is, look, if I were to go backwards to factor A squared plus 2AB plus B squared, all we have to do is we get A plus B all squared. Okay? So this is the idea. The middle term is always double of the two on the ends multiplied together. At least the A value and the B value. And then if I want to factor this, A squared minus 2AB plus B squared, then we get actually A minus B all squared. Now, if you can't actually see this right away, no problem. You can use all the factoring methods you did before, right? Find two numbers and multiply to blah, blah, blah. Those two numbers add to blah, blah, blah. That will work as well. Okay, but if you can see it, then I think this is a nice, easy, quick way of getting the final answer. Okay? So let me show you. Example number 2. Factor these trinomials. So once again, I see this as, A is equal to, not x squared, but x, right? And then that 36 is like our b, so b squared, so b is equal to 6. So knowing this, and this is a plus, can we double check that the middle term is twice of a and b? So twice of a and b, 6x times 2. Yeah, that's 12x. Ding, 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 ding. So we know we're good. We know, therefore, this is a perfect square trinomial. And then I can just write down really quickly then, x plus 6 all squared. Done. Now, once again, I told you we didn't have to do it this way. We go back to the old way. Two numbers and multiply to 36. Those same numbers add to 12. You'll find that the numbers are, 6 and 6. So you'll still get x plus 6 times x plus 6, and that, of course, is just x plus 6 all squared. Okay? I'd like you to try B yourself. Go. Hold on. Bum, bum, bum. What do we have here then? Yeah, 12 minus x all squared. Why is it minus this time? Because of the negative here. And notice once again, if I take 12 and x and multiply by 2, I do definitely get the middle term, 24x. Okay? Part C. What do I always say? I say a lot of things, I know. But I always say factor out the greatest common factor first. So let's go ahead and do that, please. The greatest common factor I see here is 2y, left with an x squared, minus a 22x, plus a 121. And I'm thinking, a is x, b is 11. I can double check once again. 11x times 2 is 22x. Here we go. X minus 11 all squared. Nice. Okay. Yeah, D. Okay, look at this. X squared minus 16x minus 64. So, hey, A is x. B is 8, and then x times 8 times 2, yeah, that's 16x, that's good, so this is x minus 8 all squared. Wrong! What? Wrong! Yes, I said wrong! Look at the form. Look at the form up here. A squared minus 2ab plus b squared. It's always a plus b squared. What do I have here? Minus b squared. This doesn't work. Actually, this one is not factorable. Tricked you. Okay. E. 225y squared minus 90xy plus 9x squared. Here we go. A equals to what? 15y, yeah. B equals to what? Yeah, 3x. Okay, let's double check. 15y times 3x times 2. 15 times 3 is 45 times 2 is 90. Yes, xy, this works. So 15y minus 3x all squared. Okay? Now, we can also factor out 3, I think, from here. 5y minus x all squared like that. That is perfectly fine as well. Okay? By the way, for this one, I could have also done this rule. Factor out the GCF. I could have done that first, and then do the same thing. You'll get the same answer in the end. Alright? And the last one, F. Yeah, wow, this looks scary. But once again, factor out the greatest common factor. How about a BD? C, D, 196, C squared. Wow, interesting. In this case, my A value would be 11D. My B value would be 14C. 11D times 14C times 2. 22 times 14, that's 308. Yes! So, this just becomes 11D minus 14C all squared. Wow, that was ugly. Okay, so a few more of these. How about factoring fully, friends? Let's do those. Okay. Factor fully says we should, factor fully, meaning factor, factor, factor. Here I'm thinking if this is A, that's x squared. If that is B, that's 12. Oh, wait a minute. 12x squared times 2, that's 24. Oh, that's 25. So maybe this is not a perfect square. So what can we do instead? Yeah, find two numbers that multiply to 144 and add to negative 25. I think there is a combination. X squared minus 9, x squared minus 16. And then we have to factor even further because now they are both difference of squares. Yeah! And this is just x plus 4 and x minus 4. Now we are done. Okay? This one looks like a difference of squares. The A value is x to the power, x to the power 8. B is just 1, so this becomes actually x to the power 8 plus 1 times x to the power 8 minus 1. One of them is a sum of squares. That's great. We don't have to do anything more. But the other one is a difference of squares. Guess what? We have to keep going. So if we were to factor this as a difference of squares, x to the power 4 plus 1, x to the power 4 minus 1, right? And once again, we have a sum of squares. That's fine. We'll keep that as is. But look, x to the power 4 minus 1, that's a difference of squares. So we can factor that again into x squared plus 1 and x squared minus 1. And this is good because now we have a sum of squares, another sum of squares, another sum of squares, and finally, yes, this becomes x plus 1 times x minus 1. Now you are finally done. Woo. Woo, woo, woo. Okay. Keep going, solving without using a calculator. Wow. Gotta do this. But wait, this is a difference of squares, isn't it? Yeah. So if this is a difference of squares, think about it like this. 75 plus 25, 75 minus 25, I know those numbers. That's 100, that's 50. I know what 100 times 50 is. 5,000. See? Done. You can do that with the same trick for this other one. This is a difference of squares again. So this is what 1 0 0 0 0 0 1 plus 9 9 9 9 9 9, and then 1 0 0 0 1 minus 9 9 9 9 9 9. Well, what does this become? Yeah, that first term is just actually 2,200,000, and the next term is just 2. I know what 2 million times 2 is. That's 4 million. I wish I had $4 million too. Okay. Alright, now we can also use this idea with, hey, a review of cylinder and, its surface area. Ooh. So a cylinder of height h has an outside radius of r and an inside radius of r. Oh, this is a cylinder with a hole in it. I get it now. Outside radius is capital R. Inside radius is little r. Okay. And then, of course, there's some sort of height. H. It says find an expression for the total surface area of the cylinder, and then also factor the expression. Now remember, the surface area of a cylinder, hopefully you remember, 2 pi r squared, that's the top and the bottom, plus 2 pi r h, that's the curved side. And so in this case, if you think about the top and the bottom, remember the top and the bottom is actually a big circle minus a small circle. So really, 2 pi r squared, the big circle, minus 2 pi little r squared, the small circle. So what I did here was actually this piece, the ring, and both the top and the bottom. And then of course there is the surface area of the lateral side. Okay, I'll do the outer wall first. Okay, the outer one. That would be, of course, 2 pi capital RH. But we also need to take into account the inner surface area wall, right? So I'll say plus the surface area of the inner wall, or inner side. And that would be what? 2 pi little RH. Well done. So that is the total surface area. But I said, now can you factor this expression? Notice that the terms are highlighted in yellow. There's a factor of 2 pi that I can take out, and I'm left with capital R squared minus little r squared. And these terms over here, they have a common factor of 2 pi h, and I can take out capital R plus little r. If you think you're done, I say no, 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 because capital R squared minus little r squared, that's the difference of squares, so that's capital R plus r, capital R minus r. And now I'm thinking, look at this, I see common factor here as well. Let's take that out. And now you're left with 2 pi r minus r plus 2 pi h. And if you're thinking, wait a minute, couldn't you have taken out the 2 pi as well? Yeah, you're right, I could have, and maybe I should have earlier. So I should have had 2 pi with an r plus r, and now we're just left with r minus r plus h. That is probably the simplest form. Cool. Alright, and some more trickier questions here. I'd like you to try to factor these lovely doozies. Yes, they are doozies. A, I see a difference of squares, if you can see that too. Our A value is x squared plus 2x. Our B value is 8. So x squared plus 2x plus 8. X squared plus 2x minus 8. And yes, our first term, can we factor? Two numbers that multiply 8 add to 2? Don't think so. But the second one we can. Two numbers that multiply to negative 8 and add to positive 2. Yeah. 4 and 2. Make the 2 negative. So x plus 4, x minus 2. Tricky, tricky. Part B. Remember what I always like to do first? GCF. Yeah, factor that out. Still get this nasty thing though. 1152 divided by 2, that's 576, I think. y to the power 4. Okay. Can you see how the thing inside the square bracket is a difference of squares? Can you see how my a value is x squared minus 10xy? My b value would be, what's the square root of 576? I think that's 24, so 24y squared. So if we can do that, then this becomes a x squared minus 10xy plus b. Okay. And then we also have a minus b. Close bracket. Here I think we can actually factor, because I'm thinking two numbers that multiply to 24 and add to negative 10. What combination works there? 6 and 4, yeah, negative 6, negative 4. So this actually becomes x minus 6y, x minus 4y. Done. Looking over here though, I see two numbers that multiply to negative 24. Those same two numbers add to negative 10. 6 and 4 don't work this time, but 12 and 2 does. Negative, so x minus 12y, x plus 2y. There we go. Ta-da. Woo! C. You've never seen this stuff before. You're like, I've never even seen one with 4 terms. Yeah, I know. But I hope you've seen something like this. Why don't you just look at these 3 terms? What does that become? You can do the two numbers multiply and use choose method. That's perfectly fine. You could also perhaps see that this is a is 2x and then b is 5. Let's just double check the middle term. 2x times 5 times 2. Yes, that's negative 20. So this actually becomes 2x minus 5 all squared. Why did I do that? Because now, can you see how this is a difference of squares? Yeah. Difference of squares where a equals to 2x minus 5 and b equals to 4y. So 2x minus 5 plus 4y, and then 2x minus 5 minus 4y. You could leave it like this, or some math people once again like having the coefficients, or sorry, the variables all done first, and then the constant term at the end. It doesn't matter to me, but both answers will be good. Okay. And if you think about D, you're like, I've never seen something with 6 terms. Well, may I suggest us split this up into 3? May I suggest that we also factor out negative from the blue part? Okay, I think I've given you enough of a hint. I'd like you to factor this, then factor that, and then do some more things. Okay? You try. You're experts at this now. And look at we have a difference of squares. So a plus b, a minus b, a plus b minus c minus 1, a minus b minus c minus 1. Are we done? Yeah. Oops. This should be plus. Right? Negative, negative. Ooh, I made that fatal mistake. Ooh. Okay. There we go. I think now we're done. Alright. I think I'm going to stop here because you're probably tired. My brain is fried. I know there's a next part, but I'll do that in the next video. This is an extension of that too. Okay? Alright, come back for the next video when you're ready. Bye for now.